welcome to my YouTube channel TensorFlow. Today in this lecture, we will learn the individual conditional acceptation. Right? So, if you are first time on this channel, please do the like, share, and subscribe, and press the bell icon. When we will upload any video, then you will get a notification. So, if you not see the previous lecture of PDP, then please I recommend it. You will go and watch the previous lecture so you easily connect with the IC and next lecture of ELA. So today we start the IC. So without wasting time. So what is the IC? Right. IC individual conditional acceptation. Right. So in IC plot, normally so the one feature change is the model prediction, right? Only for one feature. So I will take one example and I also show in the collab notebook. So there is two features, X1 and X2. I do bigger. So there is two features, X1 and X2, right? This is only for in increasing order, right? And also unique. And X2, what is the difference? Is the not a increasing decreasing means a monotonically, right? And not a unique values, multiple values, right? And this is the feature. This is the target. So this is the target is y. In that case is also unique, right? In increasing order. So what we in that case one features this one feature sends the model prediction, right? So each individual data point, right? For every data point. So PDP partial dependency plot only show the average effect of the features. I also covered in the previous lecture, right? In IC plots reveal how effects depend across instance, helping you to see where the model behave differently for different cases, right? We would discuss. And how to plot the IC, right? First, we need to train a model, right? Here, we again train the decision tree model, same as well in the PDP. So here is the two features, X1 and X2, and this is my target variable. And here we train the model of the decision tree, right? Is the black box model. So pick a features. So here we choose features is one, right? Respect to the features one, right? Then we move to the next. Make copies of the data set, right? For each unique values of the features and create a new data set. Because in the features one, we have the all are the unique value and the increase in order, right? And replace features value in each copy set of the fusion features. So the unique values while keeping all other features the same, right? In the features one, we have all the values are the unique, right? And predict run the model on all these modified data sets so get predictions, right? And for the result on the x-axis we have the chosen features. If we choose the features x1, then we have the x1. If we choose the feature x2, then we have the features x2, right? And y-axis we have only for predicted value, right? And each line, one data point showing how the predictions change as the feature varies, right? So I will try to show here. This is our x-axis. This is our y-axis, right? This is for features, right? X1, right? We plot the This plot is respect to the X1 features, right? In X1 features, we have all the unique values, right? And this is our target, right? So this is the plot I explain on the notebook more. So when we will use the IC plot, right? So in that case, model agnostic, IC work with any model, right? IC, PDP, and ALE, all models have worked with any models, right? Like linear regression, decision tree, random forest, XGBoost, all those type of the model. Why? Because it doesn't depend on how the model is built inside, not depend on structure of the model inside the model, right? And also focus, local focus, right? It helps us you to understand effect at small and local level, right? I already explained what is the local level and what is the global level. In local level, I again explained this is my complete data set and this is my subset of the data set, right? This is my local level. Instance level insights. You can see how each individual prediction sends many feature sends, right? In that case, features send. So individual prediction, how each individual prediction sends many feature sends. When we sense the feature value, then how the prediction sends, right? Individual. Each prediction sends when we are send the feature value, right? Next is heterogeneous effect. So in that case, it shows if the features impact is different across all the data point, right? And complement of PDP. IC is useful alongside PDP, right? Because PDP shows the average effect while IC shows the separate spread of individual effect, right? This is the difference between PDP and IC, right? Now we discuss the assumptions in IC, right? So in that case, features are independent, right? Independent, yeah, independence means let's suppose if we have x1 and x2, both are not depend on each other, means independent. And here we put in the data set, both the features are independent. Like x1 features and x2 both are independent because value are not like x1 equals to 2x2, not like that. So in that case, my uh, features are independent. If you have more understanding of the what is the linearly dependent and independent, then go the lecture of linear algebra, then you understand the concept of the independent and what is the dependent, right? So, I see assuming features you are sensing is not strongly tied to the other features. If features are highly correlated, right? Features are highly correlated. The plot may show unrealistic effect, same issue as PDP. So in that case, I see plot when the features are highly correlated, when the correlated value lie between 0.75 between the 1, then or correlation is highly correlated. Features are highly correlated. So in that case, same as the PDP is unrealistic effects, right? This is one assumption. Second, meaningful changes. I see assume it makes sense to the changes the features it on it arm. For example, adjusting a numeric features like temperature is fine, but changing something unrealistic like height without changing width may not take sense, right? So this is my two assumptions of IC plot. Now, what is the limitations of IC plot? First is complex visuals in IC. You already see there is the plot in the is complex plot, right? When we have only respect to the one features, when we uh, plot the multiple feature, then this is the complex plot, right? So this is the one limitations. So with many unique values, right? And features correlation. Same as the PDP. In the PDP, we have one limitation of the correlation. In the IC is also one problem is the features correlation. Correlation with the other features can lead in misleading insights, right? This is the limitation. Same as the PDP. And computational cost. Required predictions for every instance and every unique research features value, making a resource extensive, right? So now we compare the PDP with IC. What is the difference between PDP and IC? Why we need IC, right? So in the definitions, we know the PDP shows the average effect, but IC show the individual effect, right? Of features of each data point, right? And computes them and calculate the average predicted value across all the data points. But in the IC, calculate the predicted value for each instance separate, not mixture, right? In visualization, one line showing the average trend only for one line. But in the IC plot, many lines, one per instance, right? So what is the purpose of fading? Understand the overall trend of the features impact, right? But in the IC, variation in how the features affect different instance, right? So now in interpretation, smooth lines showing global influence, but not a smooth line then in the local influence and other type, right? But in the IC codes, different line showing instance specific behavior, right? So in that case, use case of the PDP when we analyze the overall importance of the features. But in IC, in different lines showing instance specific behavior. Right? So use case is when analyzing overall importance of features. When we need the overall importance of the features. But in the IC, only for we try to use case of the individual effect of the features, yeah, or heterogeneous, right? Heterogeneity, right? The relationship PDP means average of all IC lines, right? I will try to show. And IC lines are building block of PDP, right? This is the main relation between the PDP and IC plots. For assumptions, we already discussed before. So the average meaning marginal effects and same assumptions but more details viewed. Limitations hide individual differences and can look messy large data set. So I will try to discuss the average of all IC lines. In that case, so this is my IC plot. But in the IC plot, so PDP do the average of all the lines, right? And like this is my one line, right? Line. This line here is the overlap, and again this line, this line, this line, this line. So all average of all the line. Right? But here the individual line, right? All the individual lines sometimes they had overlap, right? Now I will try to show the notebook so you easily connect with IC with the 3D. So in the notebook, first again we discuss with the go through the PDP so we easily connect. So first we create the two features with x1 and x2. You already see this is my x1 features. This is completely unique, and this is my x2 features is mixture of increasing decreasing like monotonic type, and also repetition of the value. And this is my target. This is my y. This is my target, right? So again, show the data frame with the features x1 and x2, and this is my value of y, right? Then do the train of the models with respect to the decision tree. Here we train the model of decision tree with respect to the features x1 and x2 and with the target variables. So train the model, decision tree regression. Here the train the model, and again we plot the partial dependence plot. So here the we have the two features. So in the features one, here is the average, right? But again with respect to the features x2, so with respect to x1 and x2 both are together. Now we understand the individual conditional plot, right? So here what is the figure size is 8 and 6, right? And PDP partial dependency plot, right? From estimator model, and this is the one x and Fisher's respect to the 0. 0 means x1, right? And kind of the individual types, right? And Fisher's name is x1 and x2 with respect to the two users, and ax equals to ax. So set as the title, so we plot the individual condition with the plot of the x1 respect to the x1 features. So here we can see this is my features value x1, and this is my partial dependence plot, right? Right. So this is my partial plot. This in the partial plot all the values of the average, but here this is my individual plot, individual with respect to the features value of the in the x1, right? So this is my individual plot. So with respect to the x2 features, again we plot with the features x1. Features is 2 x2, but value is the 1. Why? Because when we are plotting x1 and x2, the number of the 0 and 2 starting with 0 and 2, right? So here we plot the individual plots, and when this is my line, this is line with the respect to the partial plot. This is my features x2 according to data, right? So here we end of this lecture. You and thank you for watching this lecture. The end. In next lecture we discuss the ALE plot. So continue with ALE plot. Thank you.